Today we're going to cover section 6.1, which really is about solving systems of equations. And to do this, we've got to go back to some more like pre-college algebra stuff first, and then we'll get to the actual solving. The lecture today is probably not going to take long. I might go into the next section actually, if we have time. So we'll see them. So again, this is section 6.1, and you're going to need the TI-84 calculator, 83 calculator. I'm going to start solving these using the calculator, and it takes a lot less time. And really the idea isn't about solving, it's really interpreting it, what it means, okay? So that's why we're going to use the calculator for this. So before I get to the information in the book, let's just go over what we should know already, but I'm just going to assume you don't. And it's solving systems of equations. Solving systems of equations. And let me pull up a good example that hopefully your brain goes, oh yeah, I kind of remember doing that a long time ago. It's just been a minute. Well, I said that. Let me find I don't see a good example here. I'll have to make one up. So let me make one up. Let's say now we might get really weird answers for this, and that's okay. Let's say we've got 2x plus 3y equals 6. And let's say 4x minus 5y equals 2. We're probably going to get weird answers, but this is considered a system of equations because there's more than one equation, right? We've got the top equation and we've got the second equation, the bottom equation, okay? And notice within this system, we have two unknown variables. We've got the x variable and we have the y variable. So because we have two equations and we have two unknown variables, we should be able to solve for this. Now, if you remember back to learning about these systems, they might not have a solution, or they might have infinite solutions. We're not going to worry about that today. We're just going to focus on solving the ones that have solutions, okay? And so hopefully you kind of remember going over this. There were three main ways to solve these. One, the first way typically that instructors go over is graphing. So you graph both sets of equations, right? These are linear lines. It's a kind of a repetitive thing. These are lines on a two-dimensional plane. So therefore, wherever they cross is going to be their solution. That was the first way. The two other ways, and I'm not sure what order your instructor went over them, but two other ways were solving by substitution and solving by elimination. Now, I'm going to solve this thing by elimination, okay? I'm going to solve it by elimination because it's my favorite way of doing it. And the goal on elimination is to eliminate one of the variables, okay? And look, you don't have to remember how to do this. We're going to do this all in the calculator, but I just wanted to bring it back up to show you kind of the longhand way of doing it. So if we want to solve this the long way, and I wanted to use elimination because that's the method I like the most. If you look at these x's, we've got a number that can be multiplied. The smaller number 2 can be multiplied to get the larger number 4. That's what you're looking for. If you look at the y's, you can't multiply 3 by a nice number. You can multiply by a fraction, but you can't multiply by a nice number to get 5. So I'm going to go with the 2 here. And what we did is we actually multiplied the smaller number. And when we do that, we've got to multiply the entire equation of the smaller number to get the bigger number, but we have to have opposite signs. So I'm not just going to multiply by 2 to get the 4. I'm going to multiply everything in that top equation by -2. Okay, so let's do that. We're not violating any math rules because we're multiplying everything in the equation by 2. Remember, these are nice equations here, okay? So when I do that, now I'm going to rewrite equation 1 underneath here. So -2 times 2, that's going to be -4x. -2 times a +3, that's -6y. -2 times a positive 6, that's a -12. Okay? And now, to eliminate these, you just add vertically. Look, you've got one equation on top, one equation on bottom. Everything's set up correctly for this, so we're going to add vertically. So you just add everything vertically. And what happens is your x's eliminate. That's what's called the elimination method, okay? The x's eliminate. You get 4x plus a negative 4x, that's 0x. Negative 5y minus 6y, you get a negative 11y. Equals, looks like negative 10, right? This is going to be one of those, oh, well, we get weird answers, okay? Divide by negative 11. And we get y equals 10/11ths. Okay, y equals 10/11ths. But remember, you've got two equations with two unknowns. We've got to solve for the other value, the x value. And you can go into either one of the original equations and just pop y equals 10/11ths in and solve it out. Okay, this is when it's nice when I can find examples so we're not dealing with weird fractions, but that's okay. Let's take y equals 10/11ths, and I'm going to put it into the second equation here, okay? When I do that, I'd get 4x minus 5 times, well, we know our y value is 10/11ths, right? Equals 2. And then I just solve it out, okay? So I get 4x minus, now, negative 5 times, that's going to be minus 50 over 11 equals 2. I don't like fractions, so if I can get rid of them, I'm going to get rid of them pretty quickly. There's a nice trick. If you only have one fraction in an entire equation, there's an easy trick to do this, and it's you multiply everything by the denominator. So I'm going to multiply everything by 11 here, okay? And when I do that, this denominator fraction is going to go away. So I get 44x minus, now look, because really it's 11 times 50 over 11. So that 11 is going to cancel, equals 22. So look, again, this cancels, and it leaves me with 44x minus 50 equals 22. So now it's just a basic equation. So add the 50. And I get 44x equals, is that 72? And then divide the 44. And I get x equals, now I know 72 is divisible by 4. I'm going to take my calculator out here. 72 divided by 4, that's 18. So both of these are divisible by 4. So we wind up with 18 over 11. Hey. There we go. That's our solution. Really, I should say solutions, but that's our solution. It's if you want to write it as a coordinate, it's 18/11ths and 10/11ths. Now this one was a lot harder because it was with fractions, and I made it up off the top of my head, and that's what happens when you do questions like this. Okay. But what's nice is this. Now, look, if you look at this chapter, if you're looking in the book right now in 6.1, you're going to say, well, Mr. Shirley, there isn't one with just 2 equations. It starts really early, like on 3 equations with 3 unknowns, I believe. Yeah. Ooh, one section. And that's true. And what they go through a different process to solve called using an augmented matrix. We've got to talk about what a matrix is here in a minute. So what I'm going to do now is I'm going to solve this exact system, but I'm going to use a matrix, and I'm going to go through the explanation of what a matrix is using this example. So in the end, we're still going to wind up with 18/10ths and 18/11ths and 10/11ths, but we're going to solve it a different way. We're going to solve it using matrices, and that's what chapter 6 is about. It's all about matrices. Now, it's not about solving with matrices, the whole thing anyway. When we get to the next 2 lectures, it's more about basic operations of matrices. Your book jumps right in on how to solve something we know, get you using the matrices. That's what your author does first. And there's nothing wrong with that. I mean, there's pros and cons in any ordering of any kind of math curriculum, but that's what Dr. Blitzer has chosen. Okay. So let's look at this original system of equations again. Actually, I'm gonna rewrite it. So we had 2x plus 3y equals 6, and 4x minus 5y equals 2. Okay, this was the original equation. Now, a matrix is just rows and columns. Okay, rows and columns of numbers. That's all it is. Okay. rows and columns and numbers. If you're going to use a matrix for something like this, for solving, you have to make sure that the rows and the columns, I did the backward, right? Columns and rows have something similar. And by what I mean is, for the one we're about to make, the rows are going to be each equation, okay? And that's going to be consistent throughout this section. So the first row we're going to make will be this first equation. Actually, it's going to be the coefficients of the first equation. And then the second row is going to be the next equation. The columns, though, are going to be each variable. So the first column is going to be my x coefficients. My second column is going to be my y coefficients. And then my last column is going to be my constants over there. So they have, it's extremely important that these are in a common order. Okay, that's a good way to think of it. It's extremely important that these are in a common order. It's okay if the x's and y were flipped, but they have to be flipped for all of the equations. Okay, so let's look at what this looks like as a matrix. And your book calls this an augmented matrix. Okay, the way we would write this, now we use kind of little brackets here, and the brackets are just the end and the beginning of the matrix. Okay, so I'm going to write this first equation, but you don't write any variables. Okay, variables are assumed because the first row is going to be the first, first column. First column is going to be the first variable, second column is the second variable, and then the third column is the third variable. So if we look at this first equation, the way we would write this is 2, and it gets its own little spot in the matrix. Okay, 3, it gets its own little spot in the matrix, and 6. And look, we don't have any other numbers here, so we're going to close off this matrix. Okay, and we have created the first row of our matrix. And then we're going to do the same thing for the second equation. So 4, -5, and +2. Okay, 4, -5, and +2. And we've created an augmented matrix. Pretty neat. Okay, pretty neat. And what this means is we know if we wanted to, like, let's say we didn't know any of this. If we created an augmented matrix for solving, we know that this first column is a variable where we used x, right? The second column is another variable. And the third column actually for us is our constants, right? But it's another variable, okay? We know that. So whatever number is here, it's going to have the same variable as what's on top of it. So the 4 I know has to have the same variable as 2, and the 3 has to have the same variable as -5, and 6 for 2, okay? So that's part of creating these matrices. Well, then it's like, well, how do we solve using the matrices? Now, your book goes over row echelon form, which is named after someone. I'm not sure who, but probably Mr. Echelon. But it's on page 591, and actually it goes through how to solve these by hand. And I'm not going to do that. We're going to do it a lot easier on the calculator. So before we get to the calculator, we have to talk a little bit about matrices that we're going to go over again in 6.3 actually. But we've got to talk about the order of this matrix. Okay, the order. The order is always the number of rows by the number of columns. Okay, the number of rows. So for us, we have 2 rows. Times, it's not times, but it's by, right? Like a 4x4 by 2 by 3. Okay, so the order of this matrix, we have 2 rows and we have 3 columns. So it's a 2 by 3, and this is going to be important once we start putting this matrix in the calculator. So let's do that, and I'm going to do that thing where I shove the matrix, the TI-84 up to the camera to show you every little button that we have to press. Okay, so give me just a minute. I'm going to make the floating TI-84 into the camera real fast. Got to make sure. So get your calculator out. I'll give you a minute. Get the TI calculator out, and so we can go through this. Okay. Ooh, my calculator's almost dead. I need to charge it. Okay, get your calculator out. I'll give you just another minute. Okay. So when you turn your calculator on, it looks something like this. We've got the floating calculator again, right? Now look, if you notice above the x to the -1 button right there, and I know it's really hard to see because, yeah, there it is. Woo. There's a matrix. It says matrix right there. And to get to that matrix option, you got to hit second and then the x to the -1. And when you do that, it looks like this, okay? You got names, math, and edit. Names, math, and edit. So we're going to put this matrix right above the calculator into this calculator. And the way you do that, we're going to call it matrix A, but we're going to go over to edit. So hit over twice. And the very first option is A. So we'll call this matrix A. Why not? Just so I remember what we called it, because we're going to play with it too. So just so we remember what we called it. Okay, matrix A. Okay, we're back here. So I'm going to click on A. And you can hit 1 or you can hit the enter button. Boop. And we'll see the very first thing it asks us actually is for the order. Okay, so I've got to put the order. Remember, this is a 2 by 3. So I'm going to put 2 into that first number that says 1. So I click 2 and then hit enter. And then I'm going to hit 3. And then I'm going to hit enter. And look, your calculator now, it might not look just like this. If you have a different edition, it might have a different color or something like that. But notice it created a 2 by 3 matrix. So now we're going to fill it in with our matrix A. Okay, so you put the number in and then you hit enter. I'm going to put my hand down here. But like you put the number in, like the first number is 2. I put 2 in and I hit enter and then it goes to the next number. So I'm going to do that. So 3, enter. 6, enter. 4, enter. -5, make sure with the negative you use the negative under the number 3, the actual negative number, not the minus sign. And then 2. Okay, so my augmented matrix looks like this: 2, 3, 6, 4, -5, 2, and that's 2, 3, 6, 4, -5, 2. Yeah, there's my matrix. Awesome. So now, once I have that matrix in there, I need to leave. And the way I leave is, notice next to the, above the mode option says quit. I know you can't see that because it's too close to the screen. So you're going to hit second and then mode, and it brings you back to the original screen. Okay. Second and mode brings you back to the original screen. And now what we're going to do is we're going to do some matrices math. And what we need actually, it's called reduced row echelon form. Let me write that. Remember, this is going to be our answer. So let's write this underneath here. Reduced row echelon form. And I know I haven't really talked about this, but what this does, reduced row echelon form actually creates a matrix of 1s and 0s except for the constant. So for us, for this example, reduced row echelon form, it's always going to make a 1 in the very top left cell, and then it'll be 0, 0, and then it's going to go diagonally 1, okay? Now, I don't know. I'm going to put a little line here for, that's where the equal sign was, remember? Right here. So I'm going to put the line right here. Now, I don't know what's going to be here yet. Actually, I do, because it's these two numbers, but we're going to get to that in a minute. This is what reduced row echelon form looks like for a 2 by 3 matrix. So let's find reduced row echelon form. It's going to be in that math part of the matrices. So remember, to get back to the matrices option, you hit second, and then you hit the x to the -1. And notice in my A, it's got my matrix that I could call it if I want to. I don't want to call it right now. I want to go over to math. And what we're going to look for is, I think they use RREF for reduced row echelon form. So I'm going to scroll all the way until I find it. There she is. Option B, reduced row echelon form. Okay. So I'm going to hit enter on that, and it calls it to the main screen. And now I've got to call my matrix. Remember, we call this matrix A, right? So I'm going to hit second matrix again. And now I just want to hit enter here because it calls matrix A and it puts it in. So what they're going to do, the calculator is going to do all the hard work for us, okay? The calculator is going to do reduced row echelon form on matrix A. Boom, that's too cool, okay? Now if you hit math and then frac, it'll make it a fraction. And notice the two numbers there are 18/11ths and 10/11ths. Hey, that's what we got before, okay? That's exactly what we should get. So what happens if you look at that matrix, if you look at your calculator right now, I'm going to rewrite this. Reduced row echelon form of matrix A is 1, 0, 18/11ths, 0, 1, 10/11ths. Okay, that's reduced row echelon form. Now look, hopefully you're thinking, well, what does that mean? Well, remember when we created this matrix, the first column are x's, second column are y's, last column's the constant, and then each equation goes left to right. So what we actually found here, now I'm gonna rewrite it up here because I have a little more board going on. What we found here is if we want to write this now to go from the matrix back to the equation, what we found is, remember, this first number is an x value. So 1x plus 0y, right, equals 18/11ths. That's what this first equation tells us. 1x plus 0y equals 18/11ths. The second equation tells us 0x plus 1y equals 10/11ths, right? Now we knew this already, right? We knew this already, but we're using the calculator to solve it for us. So what this did, now look, if we want to clean these equations up, 0y goes away, and this just winds up being x equals 18/11ths. And then the x goes away here, and you wind up with y equals 10/11ths. That's my two solutions for the equation. Pretty cool, okay? Pretty nifty. Okay, you guys that are in the class, do you have any questions other than, you know, I really need to see that again? My mind's hurting, my brain's hurting a little bit. Can I please just see this again?
Yeah, can we just do another one? I followed along the whole time, like in my calculator and stuff, but I feel like I need to see the steps again.
Oh yeah, we're going to do this like 3 or 4 times today. Okay. This is today's lecture. Actually, doing this is today's lecture. We're going to make the matrices bigger, but it's going to be just this. Yeah, so you're a good guy. Let's do another one that's in this same 2x2 form. Let me find, I'm sure your book goes over. Let's see, it does. It might not. Hold on. Give me just one second. I'm going to try to find an equation that just has a set of fractions. It's got just nicer numbers to it. Yeah, I'll make one up. Okay. So let's do another one. Let's do another one. And I'm just going to use the calculator this time. I'm not going to worry about solving it by hand. Okay. So let's say we had x plus 2y equals 5. And let's do 2x minus y equals, okay, hold on. Hold on. Oh, kind of. Actually, you know what? We can get weird numbers. It's not a big deal, but I think maybe this will be. Let's do minus, let's do +1 here. +1. We might get a nice number. We might not. I have no idea. I'll show you how to check it too. How about this one? I'll show you how to check it, which is kind of neat. So first though, before we get started, if we're going to use the matrices to solve these, we have to put it in that augmented matrix form. So I'm going to put it in augmented matrix form. Remember, I've got the x's on top of the x's. That's so important. If we wrote the y's here, like the y here and the x here, we'd have to flip it. So they have to match vertically. You have to match vertically, and really you match horizontally as well. It's just the equation. So we got 1, 2, 5, right? 1x, 2y, and 5. And then we've got 2 minus 1, right? And a positive 1. So here's our augmented matrix. Your book writes a little line here, and I kind of did that in the last one. Let me explain what that means. That line actually just tells us where the equal sign is. Okay, that's all it's telling us is really here's the variable matrix and here's the equality matrix. Kind of a goofy thing to do, but your book does it. And actually, it's very common for mathematicians to do this. Okay, so now again, let's talk about the order because your calculator is going to ask that. Again, this is a 2 by 3 matrix, right? A 2 by 3 matrix. And you know what? Just for fun, just to show you, I say for fun, just to show you a different kind of option in your calculator, let's call this one matrix B. So we can leave matrix A in there, okay? And we'll call this one matrix B. So let's do that part first. So remember, you're going to go into the matrix options, which I'm going to be a little lazy now instead of shoving it into the camera. You've got to hit second matrix. So second, and remember the matrix is above the x to the -1. And you get back to this screen. Actually, hold on. You get back to this screen, but now I'm going to call this matrix B. So remember, we've got to edit it first. We have to really create the matrix. So go over to edit and then go down to B. Okay. And then we've got to put the order in first. So it's a 2 by 3. Boom. 2 by 3 matrix. I'm going to put that in. So 1, 2, 5, 2, -1, and 1. Okay, so I'm going to give you a minute to do that. So 1, 2, 5, 2, -1, 1. If you guys that are in here have a question, just ask me. Something's not making sense. Okay, so now we're going to go back. Remember, we're going to do reduced row echelon form on this thing, right? So we're going to go back. I'm going to hit second and then mode for the quit. And I've got to bring up the reduced row echelon first. So second matrix. Remember, it's going to be the math because we got to do the actual operation. I think it's B down here. There's B, reduced row echelon form on B, RREF. Call that one. And then now, remember, we're dealing with matrix B, not matrix A. So I'm going to call matrix B. So to do that second matrix, and then I got to go down to matrix B now and hit enter. Okay. So it should look like this. Okay. It should look like that. So I'm going to hit enter. The numbers aren't too weird. Now look, again, I got decimal answers all the way on the right. Notice reduced row echelon form is always going to give you 1s and 0s except for the very right numbers. And notice I have decimals again, 1.4 and 1.8. Again, to get rid of the decimals, all you have to do at this point is hit the math button right there, math. Oh, wait, that's not the math button. Oh, shoot. Hopefully it'll do it. Math button and then frac. It's the very first option. And boom, it's going to give you the same matrix, but now instead of decimals, it's going to give us all the numbers in fraction form, if it's a fraction, right? Okay, so let's write this down. What we've done is we've used reduced row echelon form in this matrix. So I'm going to write RREF here. We've used reduced row echelon form, and we created a new reduced matrix of 1, 0, 7/5 and 0, 1, 9/5. So 1, 0, 7/5 and 0, 1, 9/5. And what's nice about this, again, is we can write this now back into the system of equations form. You don't have to do this. Once you see the pattern, you'll see, oh, this means x equals 7/5, and this means y equals 9/5. So you're more than welcome to do that. I just want to show you where that's coming from, especially the first few times we do this, okay? So you can put this back into the equation form, which would be 1x plus 0y equals 7/5, and 0x plus 1y equals 9/5. Okay? So this is back really in a way it's in its original form, right? We put it into the matrix form, we did some math on it, the calculator did all the math, we didn't have to, and then it pops out the back in the equation form, but we know we don't have to write 0y or 0x here. So this just becomes x equals 7/5 and y equals 9/5. So we have solved this system of equations, right? We have solved the system of equations. Pretty cool. Okay. Questions other than, yeah, let's see some more of these. I don't believe you. And actually, I'm gonna, you know, it's weird because I'm making them harder, but they're not really any harder if you're using your calculator. And by harder means I'm gonna add equations and add variables, okay? I'm gonna add some equations in here and add variables when I do that, but it's not any harder if you use your calculator. So you just have to be very careful that you code it correctly, that you put in the numbers correctly in your calculator, okay? And you press all the buttons correctly. So let's look at one. I'm going to steal an example straight from the book. Let's steal, well, where do they do this? Hold on. Yeah, there's the Gaussian Elimination Method, which is fun. Yeah, so let's look at an equation with three, or I'm sorry, a system of equations with three equations now. And this is the very bottom of page 592. The very bottom of page 592, your book does what's called the Gaussian elimination with back substitution. Again, we're going to use reduce for echelon form. We just learned it. Why not use it again? And we can use it for all of these. Okay, so wait, no, this isn't a matrix set. It's an equation. 3x plus y. It's going to be kind of a lot. 3x plus y plus 2z equals 31, and x plus y plus 2z equals 19, and x plus 3y plus 2z equals 25. So notice here, this is, and it's on the bottom of page 592 if you're following along. We've got three equations now. We've got three unknowns, and we have them set up properly, right? Our first column are going to be the x values, or x variables. The second column is going to be the y variables. Third column is going to be the z variables. Z turns out to always be 2. That's weird. And then the last column, our equation column, really are all constants. So let's create this matrix. So as a matrix, this is going to be 3, 1, 3x, 1y, 2z, and then 31, right? So I'm going to create a little line there for our, that's where our equal sign is. And the next equation is going to be 1x plus 1y plus 2z equals 19. And then lastly, we've got 1x plus 3y plus 2z equals 25. Okay, 1x plus 3y. So look, again, these equations, three equations written as a matrix, look like that. Now, one thing that is different is the order of this matrix, right? This does not have a 2 by 3 order. This is going to be a 3 by 4, right? We've got 3 rows and 4 columns. So the order for this matrix is going to be a 3x4. So I'm going to follow the same steps I did before. I'm going to call this one matrix C in your calculator, right? We already used A and B. So let's call this one matrix C. And I'm going to pop this in the calculator. I'm going to do the same exact thing. Do the reduced row echelon form on it. It's going to pop out our solutions for X, Y, and Z. Okay. So let's go back. You got to go to second matrix again. And remember, you go over to edit. Let me kind of write these steps down. So second plus, is it X to the -1? Yeah. That gets you to the matrix, right? The matrix options. And then we want to do edit. So that's step one. And so when we do that, we go over to edit. Oh, shoot. I don't want to edit matrix A. Second matrix edit. Now I'm going to go down to C here because we are going to edit matrix C. Remember, we've got to put the order in. So when we put the order in, this one's going to be 3x4. And then we've got a lot of blank spots, so we have to fill all these in. This will take a minute. So okay, make sure you do it correctly. Don't just speed through it. Make sure that each spot is correct. So 3, 1, 2, 31. So 3, 1, 2, 31. That's the first row. The second row is 1, 1, 2, 19. 2, 19. The bottom row is 1, 3, 2, 25. And now we've got our matrix. So I'm going to say step 2, put in the order and fill in matrix. Okay, so that way, if you're doing this again, and can you guys read that over there? Yeah, put in the order, fill, and then fill in the matrix. And when you get done with that, make sure to hit second quick. So I think it's second and then mode. And that should bring you back to the home screen. So second mode brings you back to the home screen. And now we're going to call reduced row echelon form, right? And to do that, we're going to hit the second matrix button again. But then now we're going to go to math and then scroll down to be reduced row echelon form, right? And then hit enter. So we're going to do second matrix, right? And then go over to math now and scroll down to B, which is reduced row echelon form. Hit enter on it. And then it'll call it to the main screen, right? So then scroll down, hit enter. And what it does is it calls it to the main screen. And now we have to call the matrix. Call the matrix. And so that's just second X to the -1. And then you just choose which matrix, right? For us, it's going to be, just for this one, I'm going to choose matrix C, right? But if you're looking at this for another example, it's going to be whatever matrix you wrote in there. So second matrix, and then now I'm going to choose C. And hit enter, and boom, it's put this in reduced row echelon form. Now, this one is an example from the book. So you can see you have nice whole number, you should have nice whole number answers, okay? So this matrix in reduced row echelon form, again, it's going to always be ones and zeros, and there's going to be a 1 diagonal here. So 1, 0, 0, 6, yeah. 0, 1, 0, 3. And then lastly, 0, 0, 1, 5. Okay. So this is our reduced row echelon form for the matrix. And what it did is it solved the matrix. It solved 3 equations with 3 unknowns. Okay, guys, I know I'm not doing this by hand, but this takes a lot of work. This takes a lot of work to solve 3 equations with 3 unknowns. Yeah, you're more than welcome to watch a video on how to do this by hand, and you'll see they take a while to do. Unless there's a lot of editing with that video, it's going to take you a lot of time to actually solve this by hand with 3 equations and 3 unknowns. Okay. Now, what does this mean though? What does this tell us? Now, again, it tells us that 1x plus 0y plus, now do we use z, right? 0z equals 6. You don't have to write this part, right? 0x plus 1y plus 0z equals 3. 0x plus 0y plus 1z equals 5. Okay? That's what this tells us in non-matrix form, right? In the equation form. So, but really what it tells us is that, look, these are zeros, these two are zeros. So x equals 6, y equals 3, and z equals 5. That's our solution. Now, what this actually is, remember I told you how in the other 2 equations, it was a 2-dimensional plane and it's where they crossed. This is a 3-dimensional plane, okay? So we have 3 dimensions here, and this is where the 3 lines cross in a 3-dimensional plane. Now, not all lines cross, right? For 2 dimensions, you might have parallel lines, right? So not all lines cross, especially in 3 dimensions. And if you have that, you just have a no solution equation, okay? And I'm gonna, if your book has one of those, I'll do one here in a minute. But you might wind up with no solution. Okay. Let that soak in just a minute. Questions from you guys? You have a question, Kylie? I saw it pop on there.
No, I was just thinking, no, I don't have any questions. I'm just watching.
That's fine. And I'll tell you, this is definitely a not a spectator section, right? You're really gonna have to get that calculator out and maybe go back and watch it. And you hit pause on me a few times and watch it and make sure it's in the calculator correctly to get to the final answer or to the final solutions. Okay. Yeah, definitely not a spectator. What's up?
Oh, I was just saying, okay.
I got you. Yeah, and so your book uses a lot of different ways of solving, and I want you to use this. So your book's going to use different methods of solving matrices, which there's a lot. Just stick to this one. We're going to go over this one, and that's what we're going to really stick with. Okay. Cool. Let's see if I can find one without a solution. Let's see. Oh, here we go. It's in 6.2. So I just want to see what happens. Honestly, I don't know exactly what the calculator is going to say. So let's see what happens on this one. So this is an example from the next section. And I know I need to do one. Hold up. Okay, yeah, we'll do this one. It's just the example. So this is actually on page 603. And we're going to do the same thing. It's going to look very similar to this one. But we should get a no solution because what's really happening is that these don't cross. These 3 dimensions don't cross at any single point. So this is on the top of page 603. So I'm going to just use this equation or these equations. So we've got x minus y minus 2z equals 2, 2x minus 3y plus 6z equals 5, 3x minus 4y plus 4z equals 12. Okay? Your book does the same thing it's always done. It puts this function or these equations, not functions. Yes, they're functions. Individually, they're functions. But it puts these equations in the augmented matrix. So to write it as an augmented matrix. Look, I'm going to check this, but all the x's and all the y's and z's are on top of each other. So we're good. Okay? So we're going to do 1, negative 2, and 2. 2, negative 3, 6, and 5. 3, negative 4, 4, and 12. Okay, so we wrote that as an augmented matrix. And now I'm going to follow my 4 steps I've written up here, so I don't have to put my calculator up to the screen every time. Okay, but I'm going to follow the 4 steps over here to solving this function, really creating the reduced row echelon form of this equation. So I'm going to, you know what, just to be lazy, I'm going to call this one C again, because C is already a 3x4 matrix, right? So to do that, you would follow the same steps. Go to second matrix, edit, and then go down to C and hit enter. And notice C is already in there, like C is from before. I said the C before. And I'm just going to put these numbers in instead of the numbers before. So I'm going to put in, you have to hit enter, enter. I'm going to put in 1, -1, -2, 2, 2, -3, 6 and 5, 3, -4, 4 and 12. I'm going to make sure this is the same exact, or the matrix out there. So 1, -1, -2 and 2, 2, -3, 6 and 5, 3, -4, 4 and 12. Yeah. Okay. So I have this now. So I created this, so I just put it on top of C. If you want to make this a new matrix, you're more than welcome to. You can call it whatever you want to call it. It doesn't matter. The main thing now is we've got to put this into reduced row echelon form. So let's try to do that. So when we do this, so hit second quit, right? That's the second step. Put in order, second edit. We did this part. Here's second quit to get out. And then now we've got to call the reduced row echelon form. So second matrix, math, reduced row echelon form. And remember, I called mine C, so I'm going to bring up C. Oop. Hold on. Gosh darn it. I'm hitting the wrong buttons feverishly. Well, it's saying that we can do it. It's really that we can't. I'm going to show you why this shows we can't. Because when you put this in reduced row echelon form, you get 1, 0, -12, 0. Notice it's not, it didn't put it in the right form. This should be a 0, right? The only value to the left of our equal sign should be zeros and a 1. Okay, so automatically let's put it in this wrong form. 0, 1, and then was it -10, 0. And then the last line is really what gives it away. 0, 0, 0, 1. Okay, there's no way that 0x plus 0y plus 0z equals 1. Do you guys see that? That's what this last equation tells us. 0, 0, 0, 1. Well, we know 0 plus 0 plus 0 is 0. It is not 1. 0 does not equal 1 here. Okay? Not here, not anywhere. So therefore, it doesn't automatically say no solution. You have to grab it from the matrix, okay? You have to really grab it from the matrix and say, hey, 0, 0, 0, 1 means that 0 equals 1. That's not reality, okay? 0 does not equal 1. So therefore, this means we have no solution. Now, no solution, we would just write a big circle with a line through it. That's not a 0. It's a circle with a line through it. Okay? Okay, I wanted to do that one just because it was a little different. And I want to do one more. Actually, this last one, I'm not going to do completely. I just want to do what your book talks about because it's it gives you some different equations, actually. Let's do one more, and then I'll give you the homework. So I'll leave that up there for you. This is, if you go back to 599, this is homework at the beginning of 6.1. It says write the augmented matrices for each system of equation. Let's do an even number. Let's do 4. 4 says x minus 2y plus 3z equals 9. Y plus 3z equals 5, and z equals 2. And I wanted to do this one because it's totally different than the previous ones we've looked at, because all like 4 or 5 of the matrices we've done so far, they had components for every equation, right? The second equation doesn't have an x. The third equation doesn't have an x or a y, right? If you write these as equations. Now it's number 4, but we got equation 1, 2, and 3. The second equation doesn't have an x. The third one does not have an x or a y. Now you can still make an augmented matrix out of this, but to do that, you must use zeros for the variables that are not present, okay? So if I'm gonna write this as an augmented matrix, the first equation, I'm still gonna use x's first. So this first column is gonna be my x's. Second column is gonna be my y's, so -2, 3, and then 9, right? So x, y, z equation, right? Constant. The second equation, though, does not have an x, so we're gonna use a 0 here. You cannot leave it blank, okay? You cannot leave it blank. You have to write a number in the cell, so we're in the position. So 0, 1, 3, and 5, okay? 0, 1, 3, and 5. And then lastly, we only have a z here. So we don't have an x, we don't have a y, we have one z. We actually know what z equals, right? Z equals 2, okay? It's done part of reduced row echelon force, but this is the augmented matrix for an equation that looks like that. I wanted to go over that because we had not done one that had a kind of a trickier augmentation, okay? Okay, so for homework then, I want you to do, 1 through, let's look here. Because I'm going to choose some from a few different sections. And look, other than the first one, so page 599, section 6.1, 1 through 7, it asks you to write the augmented matrix, do that, okay? The rest of these, I want you to solve. So hold on, let me see here. Yeah, 21 through 37. So I want you to write the augmented matrix here. 21 through 37, I want you to solve. They use the Gaussian Elimination Method. I want you to solve it like we solved before today, okay? Using reduced row echelon form. And then I'm going to choose some from the next section, so 6.2. And I want you to do the same thing. So page 609, which is section 6.2, I want you to solve using reduced row echelon form. So I want you to do 1 through 23 odd. This isn't that many questions really, because we're just doing the odds on all of them. Actually, these are odd as well. I know I didn't write that, but they're just odd.